So first thing I wanted to talk about to you guys was the exam mode. So in previous years we haven't had invigilators checking graphical calculators, but it's because we've had maybe 1% of our students with them before. This year about a quarter of our students have graphical calculators, so the invigilators will be checking that their memories have been wiped. Easiest way to do that is to put it into exam mode. So your calculator comes as a default with the IB exam mode, which is fine, and you could use that for your A-level exams as well. But exam mode 2, which is specifically made for A-level students, is slightly better. So how you install that is all on that document. If you click that link, if I just make this a bit bigger. If you click that link, it'll bring you up to the website. You've got to install something, and then it's just like updating your iPhone OS. So plug it in, update the software, and then you'll have exam mode 2. So I'm going to get you guys to put your calculators in exam mode 1, just so you can get an idea of what it's like. And exam mode 2 is very, very similar. So if you turn off your calculators, hold down the E and the M button. So I'm talking about the letter keys there. So if you look for the red letters above each key, I think they turn out to be the COS and the 7 buttons. So hold those down while it's off, and then hold down the on button. And keep them all held down until you see would you like to enter exam mode. Everyone managed to get it? It's a bit tricky sometimes. So yeah, if you push yes, it'll put it in exam mode. I'll tell you that in a minute. So for now, just put it in exam mode. I obviously can't do this with my one on the screen, but I did film a video of me doing it earlier. If I can find the desktop. Alright, so here's me yesterday putting it in exam mode so you guys can see what to do. So I think this is the UK one, I think. That's UK, yeah. So exam mode 2, this is the one you won't have on yours yet, but after you've updated it, you'll get exam mode 2. You push the U and the K buttons, which is what I'm doing there, and it's the same option as you see for exam mode 1. Push yes, whatever, blah, blah, blah. It gives you a warning about it not being available for IB. And exam mode 2 has that magenta border, whereas yours will now have a green border, I think. Yeah. Okay, so how do you get it out of exam mode? It'll either stay in exam mode for about 12 hours. So in 12 hours time, so at 1 o'clock in the morning, your calculators will go back to normal. Or there's 2 other ways to do it. So when you've got the calculators, it came with that headphone style jack lead. Yeah? If you plug that into your calculator and another calculator that's already unlocked, you can then unlock your calculator with their calculator. The instructions for how to do that is on this document as well. The easiest way though, other than waiting 12 hours, is just to plug your calculator into a computer. So that's what I've just done in this video. You literally plug it in, turn it back on. You can see I'm having trouble connecting it because I rushed things a bit. So plug it in, it'll ask you what kind of mode you want. You say flash mode, and then literally just unplug it, and it will be out of exam mode. So I'm waiting a second because my Mac's being slow. Unplug it, and then it'll say exit exam mode, turn it off and on again, and you're back to normal. So if you want to take it out of exam mode right now or after this talk, you can just go to any computer in the college, plug it in, hit flash memory, and it'll go out of exam mode. But invigilators will be checking that for your actual exam, so please can you guys, yeah?
Does it matter if we just put it into exam for me?
Right now? Yeah, it's fine. In 12 hours, it'll go back to normal.
I didn't know if like once you get
Or for the rest of the day, it will still work as a perfect graphical calculator. It just won't be able to, I don't know, whatever you wouldn't be allowed to do in the exam.
What aren't you allowed to do in the exam?
Stuff like having games on it, stuff like writing essays on it or holding equations in it, all kind of stuff. It's basically got a memory so you could type things into it. So exam mode means you can't access that memory, so it's completely wiped. Okay, in the top corner you've got an R flashing. That's because they're quite smart at Casio, and they thought, well, students might put their calculators in exam mode 11 hours before the exam, and then during the exam it will come out of exam mode and have all of their cheats in it. So that R flashing, it flashes fast for the first 15 minutes, and then it slows down. So if invigilators check your calculators and the R is slowed down, it means you put your calculator into exam mode too early, and that you might be planning to cheat with it. So put it in exam mode right before you go in, 20 minutes before you go in the exam, hour before you go in, whatever, do it, and then it will be fun. Okay, anyway, back to how it actually works then. So, right, basic calculations then. So if you guys could go to run matrix, which is the first option in the top left corner there. This is your standard calculator. When you do that, you will see on the top you've got some icons. So you've got math, rad, what's you got? Norm 1, D over C, and real. So all you really need to worry about here is that it says those terms. That's kind of basic setup that you want to keep your calculator at. Rad obviously tells you if you're in radians or degrees. So it's quite useful. You can check by just looking at the calculator, see if it's in radians degrees. Norm 1 means it's going to show everything in proper kind of like base 10, so you won't have weird decimal places or anything like that. D over C shows fractions as real fractions rather than decimals. So those are the settings you want it to have, and I've put that on your printouts as well. But it's good that you can check if it's in radians or not. If you want to change it from radians to degrees, then if you push Shift and then sorted now. Shift and then menu, you can bring up the main settings for the calculator. It should already be pretty much set up. A couple of things you might want to change. Where it says derivative, I would turn that on because later on it will give you gradients of functions when you plot them. So it's quite useful to keep derivative turned on. And then under that you've got the angle units, which lets you change from radians or degrees. So deg for degrees, rad for radians. So if you change that to whatever you want, radians or degrees, hit exit, it'll then take you back to the standard calculator. All right. So icons on the bottom. So you can see we've got jump, delete, mat, VCT, and math. These are your function keys. So the top row of keys will be new to you guys if you haven't had a graphical calculator before. So F1, F2, F3, F4, F5, F6. Those buttons do different things depending what menu you're in. So for this menu above, jump would be F1, delete would be F2, mat would be F3, and math would be F4. So every menu has a different kind of functions assigned to those function buttons. Right, other couple things. Execute is your equals button, so that's execute right down at the bottom there. A couple other bits you might not be aware of. The minus sign is a minus sign, so for negative numbers, whereas that sign is a subtract button. So you've probably not needed this before. It's a bit more important on graphical calculators. Please, can you guys try and use that sign when you mean minus, so -2, -x, something like that, and this sign when you mean subtract. Usually it won't have an effect, but there's a few functions on the graphical calculator where it does matter what sign you're using for minus and what sign you're using for subtract. So just try and get yourself in the habit of using the appropriate key. When you do some calculations, if I do, I don't know, 5 times 6, just do a few calculations, 3 plus 2. You can see it saves all your old calculations. So that might be annoying or it might be useful depending what you're doing, but you can scroll back and see what you've done so far. You can also scroll up and edit things. So say I wanted to change this calculation, I can then go in, delete a bit of it, redo it, a different number, and recalculate it. Cool. All right. So next bit is saving things in constants. So this might be quite useful. You can do this on standard calculators as well, but it's a bit more powerful on the graphical calculator. So let's say we wanted to save an answer. So a useful one you might want to save might be 9.8, which is G in mechanics. So type in 9.8. I know there's the difficulty, maths and physics use different values for G. If we save this one, you can just always use this for maths. So we're then going to push this arrow key. So this arrow key saves it. Whatever your last answer was on the screen, it's going to save this to whatever letter we choose. So we can choose out of all of these alpha keys, A right through to Z. So if I save this, push alpha lock to choose one of the letters, and I'm going to choose G. If I then push execute, the letter G now stands for 9.8. So you've saved the constant of gravity as G, and you can use that when you want. Putting it in exam mode will probably get rid of that. So you might want to do that when you get in the exam, and then you've got G set up for your mechanics. So if you try recalling it, we can do alpha, G, hit execute, and it'll type 9.8 on the screen. I can also put it into equations, so I could do like 2 times G. So 2 times alpha, and then find the G key, and you get 19.6. And you can do that for anything. So you don't necessarily have to save G. You might want to save an answer that you're going to use a few times in a question. So you can just save it in as one of the letters and use it. Alternatively, you can always just scroll up and down and look for answers that you had earlier on in the calculations. All right, so looking through these menus then. So there are some functions, if you look at the calculator, that you won't see that you used to have on your old calculator. So, for example, log of a different base. The only log button you have on your calculator in front of you is log base 10. So maybe you'll want to find log of a different base. So if there's something you can't find, there's 2 places it could be. One of those places is in this math function. So if you could all push F4 when you're on the main screen and go to math, you can see it opens up another menu of loads of different functions. So things that might be useful, we've got log AB. So if you try pushing F2, it'll put in the log with a blank base, so you can type in numbers there. We can also put in modulus symbols. So first, you probably won't know what that is yet, but modulus signs are there as absolute values. So if you want to use those, so you put moduluses in. And you've also got the other functions. You can differentiate things. So we could differentiate, I don't know, 2x squared. Put in a value for x. And it will find me the gradient at that point. Okay, you've also got a second derivative, integration sign, and summation sign. It's a bit complicated now. But you can fill in those bits with whatever you want and work out numerical values to sums, integrals, and differentials. Cool. All right, say you wanted something that you couldn't find in that menu, or we could go back, exit everything. The other place something could be is in the option menu. So far we've looked at the math menu, which is there, and the option menu, which comes up when you push the option key. So if you push the option key, it brings up another load of stuff. I've gone through these kind of briefly in the guide I've given you guys. So list, you probably won't use that often. You might use it in statistics if you want to work out mean, medians, mode, but there are better ways of doing it. Calc is a very powerful calculation device. So if you bring up the calc menu, you should see what's on screen there. So you've got dx, again, differentials, second derivative, integrals, and then you've got this thing called solve n. So solve n, I'm not going to go into today because it is quite complicated, but it's an amazing tool that you can use to solve pretty much any equation. So you can check all your answers to any equation that you have to solve in the exam. But I'll save that for next week because it does take some time. But that's where it is. And if you ever want to go to the next page, you can see you've got this arrow here that stands for next page. And you can see some other functions. So log is there as well. So they put log AB in 2 different places. And it's the same function in both places. Cool. If we go back a set, so push exit and it'll take you back a step. We've also got the stat function, which will be really useful for statistics. Again, in there we've got standard deviation, variance, and some distributions. I'll be talking a lot more about that next week as well. And on the next page, we've then got probability, which is where you find your factorial, your NCR for your binomial expansion, and a random number generator. So if you want NCR, it's within the stat menu from the option menu. So option, stat, there's your NCR stuff. Probability, sorry. We've also got numerical, which is, again, you can find modulus in there as well, although it's already in a different menu. I don't think we'll be using just the rest of this. Yeah, that's pretty much all of it for those 2. So any functions you can't find are either going to be in the math function key or in the option key on the calculator. Right, has anyone got any questions about those bits so far? I'm going quite fast, but there's quite a lot to get through today. No? Cool. All right, moving on then. So let's skip down a bit. Okay, next thing I want to show you guys is a function called verify. So if we clear the screen, let's push exit a few times. I don't know if you guys typed anything in. Delete all will clear everything so far. So you can use this calculator to check whether you've factorized things properly, whether you've simplified things properly. So I've got a question somewhere, I hope. Have you got those worksheets? Is there a bit of paper on the back with a partial fraction on it? Yeah, I'll have a bit more. Oh, I've lost that. Yeah, this one. I won't use partial fraction example I was going to use. If we type in a quadratic then, so let's say, so the other thing, by the way, this key here is the key you use for x. So if you ever want to do some algebra or you're plotting a graph, that's your button for x. Don't try and use the alpha and then the letter x, that's just a letter. To use a variable like x, you need to use that button there. So I'm going to type in a quadratic. Let's try x, a nice easy one, x minus 2. X plus 1. And let's say for some reason I wasn't very confident at expanding quadratics. I can now put in an equals sign. So if you go shift and then the point button, that gets you an equals. Could you guys try and expand those brackets for me and write the answer next to it? Don't worry if you get it wrong. I'd actually quite like some of you to get this wrong. Shall I get it? Maybe I'll get it wrong. Lead by example. So I've clearly made a mistake. Okay, so if you guys have done it right, if you hit equals now. Oh, actually, well, sorry, one more thing. When you've typed that in, if you could, actually, you might need to skip this step. Hit equals when you've done it. Mine's going to say 0. Yours will probably say 1 no matter what you've typed in. But there's, yours says 0 as well. Yours might already be set up. There's one thing we need to do first. So we're going to save a value as x. So what this verify thing will do is it will check if you've expanded things correctly. Obviously I've done mine incorrectly, so it said 0. 0 means false. So I've done something wrong and it's false. Could any of you guys give me the correct answer to this quadratic? What should the b coefficient be? Anybody? Minus 1, yeah. And what should the c coefficient be? Minus 2. So I type that in, now it's 1. So now it's true, I've done it properly. I mean, obviously that's a very easy example, but you could use that for partial fractions. You could use it for expanding cubics. You could check your long division with it as well. Basically, anything you're simplifying, you can type it in and verify. Now, verify only works if you've already given the calculator an x value. So I've already done that. You guys, I don't think, have. So if we type in, let's go for minus 0.1, so minus 0.1. I've chosen a minus because we want to make sure whenever we've got, you know, like a binomial expansion with a cubic, that we get that minus sign to tell us if we made a sign error. So we put minus 0.1 in. Now we're going to save x. So we're going to go answer. Again, we're going to save that value of minus 0.1. This time we're going to save it to the x variable. So answer saved to x. Hit execute, and that's all done. Now if you do that check, it should give you a 1 if you've done it correctly and a 0 if you've made a mistake. So if you want to try that, I don't know, we could try a really easy one. Let's do x brackets x take 2. See if you guys can expand that. Try one that's correct, one that's incorrect. And you should be able to get it to verify if you've expanded it correctly. So I really think partial fractions in second year is a really good use for this, because you see lots of people making mistakes finding A, B, and C. This will make sure that you know if you got it wrong. Sorry, if it's
wrong.
If it's wrong, it'll say 0. It just means false. What you've typed in is false. If it's correct, it gives you back a 1, which means true.
Why did you need to use minus 1.1?
Okay, you could go for any number. If you do a positive number though, a positive number cubed will always be positive. Yeah? If you have a negative number cubed will be overall negative. So by having that minus in there, it lets you do an extra check that you haven't made any sign errors. Because otherwise it might tell you you're correct when you got it wrong.
Yeah, but it works when I didn't put
Yours might have been saved as x equals 0, and then it will always be true because you're just getting rid of all your x's. So, yeah. All right, again, it's not completely foolproof, but it's a better check than anything else you got available, really. Okay, deleting stuff. So you can use F2, which is the delete key. You can see there the function delete. You can delete a line, which is the current line you're on, or you can delete everything. So delete everything, do that. You've also got the delete button down here for deleting individual bits of equations. And you can scroll around and change numbers as well. So that's all pretty straightforward. We've gone through the minus sign, that's fine. S to D will change fractions into decimals and vice versa. So you've probably seen this before, 0.5. If I go S to D, it makes it a half instead. That will also change mixed numbers into top-heavy fractions, but you shouldn't really be using mixed numbers at A level anyway. If you are given a mixed number, you need to turn it top-heavy. You can use Shift and then the SD button to do that. X theta t, which is the variable button, we've already talked about that. So at the moment it's saying X, it will change depending on what kind of functions you're messing around with. And one of the other useful buttons is the catalog button. So let's say you couldn't find something on your calculator. So last week when I got mine, I was trying to do an inequality. Couldn't find an inequality button anywhere. So had a look on Google, and there's a function called catalog. So if I delete all these, so if you push Shift and then 4, which says catalog on it, it will bring up a list of everything the calculator can do. So scrolling through this list, looking for inequalities. I happen to know they're right at the bottom. So scroll down. You can search alphabetically, but because inequalities are signs, I wouldn't know what to type in to find them. Can I go page down? No. So anyway, this is all the things the calculator can do. Half of these you'll probably never use or never understand, but that's fine. So yeah, anything you can't find anywhere else will be in this menu, or failing in every other alternative. But I think, yeah, you get the gist of it. Eventually you'll find inequalities right at the bottom. Yeah, so there we go. Root signs, power signs, negative powers, fraction signs, and finally we see some inequalities. Cool. All right, the last button I'm going to show you guys is the power button. You've probably seen it before. If you want to do like 2 to the power 50 or something like that, if I exit that quickly, the power button is this hat button there. It looks natural in your displays, but that's the kind of mathematical universal for power of something. So for any indices, that's where it is. Right, so we've gone through the basic setup already as well. I've given you guys a list in this document of the basic settings for the calculator, because always get students come to me saying, I've broken my calculator, I've done something weird to it. Those are the settings that you want to keep. So if you ever do break it, go back and change those. Karen?
How do you actually do inequality then without using the catalog?
Sorry, inequality without using the catalog. I don't know. I'll show you. I don't think it can actually solve inequalities though. You can only do that via plotting them as graphs.
Just plotting like an inequality on a graph.
Yeah, you can do it like a graph. I'll show you that later though. That's really easy to do. You don't need to look for the catalog. I was just trying to be clever and see if I can make it solve linear inequalities without having to do any of that, but I don't think it can. So that might be the one thing the class whiz is better at, is instantly giving you inequality solutions, whereas on the graphical you do have to plot a graph and then read the graph to find your inequality. So one solitary thing the class whiz might be better at. Yeah, it takes as many as you want then. Right. Okay, so next bit, we're going to go through some of the basic functions. So if you guys could go back to the menu. And we're going to look at the equation solver app, which is similar to the one you got on the class whiz. So if you look for equation, it's this orange one here. You could also type in alpha A if you want to skip straight to it. So you've got 3 types. You've got simultaneous, polynomial, and the last one, which is just a vague solver. So simultaneous equation solver will solve quadratics, cubics, and higher degrees. You guys will only ever need to do power 2, power 3, possibly power 4. So if we try clicking F1, you got to tell it how many. Oh wait, sorry, I've clicked the wrong thing. Sorry, simultaneous equations first. It will only solve linear simultaneous equations. So only kind of things you see in mechanics or when you're trying to solve where two lines meet each other. So normally we're going to have two unknowns, x and y. All you've got to be careful of is that all your x's and y's are on one side and all your numbers are on the other side. And you type in some values, hit equals, and it will tell you the set of solutions that solve both. So I've got an example on the sheet. I would like you guys to try this. So I've got two simultaneous equations there. Can you type them in? I've already put it all on one side for you, so it should be pretty straightforward. Could you guys try to solve those? Oh, mine's already done for me. Brilliant. I don't know if that should be 72 there or a 7. I think I might have typed that wrong. Yeah, that should be a 7, so please delete the 2 if you have it on your printout as well. Cool, so when you've done that, type it in. You can either hit solve at the top or you can hit execute. Either way will do it. You should get 5 and 2 as your answers. Okay, everybody right with that? So that will solve your simultaneous linear equations. If you did want to solve a quadratic and a line, the only way to do that is to plot it as a graph, but I'll show you that in a minute. So you can do non-linear simultaneous equations, but you've got the extra step of plotting a graph and analysing the graph. So it'll do a lot more than what it does here, but in this menu you can only do linear equations. Right, so if we go back a step, hit exit again, and we'll go back to the equation solver menu. Next one on the list is polynomial, which is what I was describing before. Solve cubics, quadratics, quartics, quintics, all of that. So click on there. If you've got a quadratic, you're going to choose 2 because we're looking at x squared. If you've got a cubic, you're going to choose x or 3 for the degree. So these basically tell you what power equation you're solving. So I've come up with a quartic for you guys to solve. So you can see it on your sheets in front of you. Could you guys try and solve this quartic for me? So you want degree 4 because it's a quartic. Type in all of your coefficients, so A, B, C, and D, and it shows you up at the top. A is the x4 coefficient, B is the cube coefficient, squared coefficient, x coefficient. Oh, and A0 is your x4 coefficient. Right, so when you've typed it all in, hit solve, and it will give you the solutions. So here we've got a solution of x equals 3. We've got a repeated solution at x equals 1, so that'd be a repeated root on the graph. And we've got a 0 solution, so one of our x values is actually 0. Cool. Right, has anyone got any questions at the moment about equation solving? No? All right? Cool. All right, so if we go back a step, the last bit is the solve function. Now, guys, the solve function, I was trying to find a use for, and it's not really that useful. But in mechanics, it could be quite useful in Suvat, because with Suvat often you have a number of variables you know about something. So you might know its initial speed, its displacement, its acceleration, and you might be asked to find other variables as well. So if you try solver, I've typed in one of our Suvat equations, s equals ut plus half at squared. And the way I did that, if I go on delete, is literally typing in with letters S. This might take a while. If you guys want to try too, type in the see that equation, up to you which. S equals UT plus half AT squared. It's a bit fiddly. Oh no. I can cheat because I have a keyboard, but there you go. So if you type in any equations, see that as what sprung to my mind as being useful. Oh no, what have I done? Syntax error. There you go. Once you type it in, it'll give you a menu and you can choose what to type in as your values. So this will solve an equation for any of the values you like, but you have to fill in the other values. So I filled in my, let's pretend we want to work out how far this particle is going to move. And let's say we're dropping it. So I've said my initial velocity is 0. Let's say we drop it from 10 meters up. So I'll put 10 in there. So we want it to displace by minus 10. Initial velocity is 0. We're going to work out how long it's going to take to hit the ground. So 2 there is going to change. And my acceleration is minus gravity. So we highlight the variable we want to find. So I want to find out how long it's going to take to hit the ground. So highlight T, and then I'm going to go F6, solve. Yeah, so hover over the one you want it to work out. So at the moment it says 2, that's not going to be correct. Push solve, and it finds it's going to hit the ground after 1.3 seconds. So I don't know if that's very useful. I was trying to find a use for it. You might find it easy just to solve it with paper and basic calculator function, but you could use it to check things if you wanted. Okay, so now we're going to go to the main bit of this, which is the basic graphing skills. So I'm going to show you a bit of this today. The rest of the graphing is going to be done next week. So we'll just kind of scratch the surface today. So if you could all go back to menu. And then we're going to choose graph, which is the purple one, which is number 5. So if you type in 5, it will go straight to it. Okay, so when you've got the graph menu up, it does look quite confusing at first. Basically, you can plot as many different functions as you like. I think you get room for up to 20 different functions. Not sure why you want them. You can choose the color of each curve. So we've got at the moment blue is our. I'll type in an x squared there. So if I delete that, yes, x squared. So if you want to put x squared in as y1. And you can change the color and the type of that by using, style, tool, and then style. So you can change if it's dotted, and you can choose which color you want to apply to x squared. Right, so we're just going to try and draw that. I think we'll all get different results because your calculators are all probably different levels of being set up. I happen to know this one's been set up quite well, I think. So draw that, and you come up with a lovely x squared graph. If you all managed to do that. Zach, you right?
Yeah, all good.
All right, good. Okay, so that actually turned out quite well, so that's probably quite a good sketch. We wouldn't want to change that much. However, a lot of the time when you sketch something, it will not have any of the details that you want. So if I try sketching...
I'm so sorry, Willie.
Sorry? Might want to watch the video to catch up there. Yeah, if I try sketching sine of x instead. So if we go back and type in sine x, Actually, before we do this, I'll show you how to change the things. So if we go back to x squared, let's do it slower. So let's say it didn't look very good and I wanted to zoom in on a bit of the graph. What you can do in the function keys up the top here, guys, because it's a graphical calculator, these function keys, the writing above them only relates to graphical stuff. So before, when we've seen that they relate to whatever it says on the screen, when you're plotting graphs, they actually do what they say in the yellow writing above. So, so important ones there, we've got trace, which will let us kind of scroll along the function and find any x value and any y value and the gradient at any point on that function. It only gives you the gradient if you turn derivative on earlier in that main menu when I told you guys to. So scroll along and find you any points, that's kind of useful. If I go back to trace again. The major one here though is view window. So if you go click F3, which is view window, it'll bring up this screen. This lets you choose what of the graph you see in your, if you like, window. So in the screen, it lets you select what you see. So I know it looks quite good because mine goes from -10 to 10 for x and y. However, when we looked at my graph, we were wasting all this space. So the graph doesn't go down there, we may as well get rid of it. So if you go to view window, I'm going to start my y values at 0 and try drawing that again. So exit, draw. You can now see it takes up the whole of the screen, which might be better. Again, this also looks quite kind of squashed, so maybe we want to see some less x values. So maybe we want to go from -5x or -5 to 5 and try drawing that instead, and we get much better shape for our quadratic. Cool. Right. So on that view window, we've got a few different options. You can change the starting point of x and y, which is the x min and y min and y max. You can also change the scale. So the scale is how often the graph puts in a little dash on the axes. So for the graph I just plotted, you can see our scale goes up in ones all the way up to 5. I might want to change that, and it's very useful to change that if I'm plotting a trig graph. Right, so what I want you guys to try and do is plot sine x and make it look quite good. So if you go back to the graph menu, get rid of x squared, type in sine of x, which you should all be pretty familiar with, plot it, see what happens, and see if you can make it look better only using that view menu option. So you can see my one looks absolutely awful. So how are we going to fix that? So have a little play on yours, guys, then we might get some suggestions to fix the one on the main screen. One thing you might want to think about is, are you in radians or degrees? Will that matter? How will that change what the axis looks like? So have a think, have a play around with it. Very good, Dan, very good. Alright, so let's try and change this one to make it look more like a sine graph that we all know. So if you go to view window, first of all, am I in radians or degrees? So if we look at the top, I'm in radians. So when we're doing this view window, we need to keep that in mind. Okay, what do you reckon I should do then? Give me some ideas what I could change.
Y minimum to maximum.
Y min to maximums, yeah. What would be a good y minimum maximum for a sine graph? 1 and -1. So we're going to change the range of our function to make it 1 and -1. So y min -1, y max 1.
You can just press trig.
I can just press trig, well spotted. So there's a trig button there, which will make everything a bit better. We're still going from -9 to 9 though. What would be a sensible X domain for our trig?
Yeah, -2 pi and 2 pi.
-2 pi and 2 pi, so we'll see the whole classic waveform. So let's type that in. -2 pi. So 2, shift, and then the button at the bottom there to get pi. It'll show it there as -2 pi. When I hit equals though, it'll turn it into a decimal. Not ideal, but it's better than nothing. And do the same thing for the max as well. Okay, what would be a good scale then? How often do we want there to be a dash on the x-axis? Pi over 4. Yeah, that could. I'd go pi by 2 normally, but pi by 4 would be fine as well. So for the scale, I'm going to do pi by 4. See how that looks. And the last option there is dot. Never change dot. Dot's weird. If I change dot, it'll ruin the whole rest of my graph. So I'll just leave that to itself. Exit, draw, and we got a lovely sine graph from 1 to -1. Don't know why it's done that now. And you can see we've got our x values are divided up into pi by 4s. So we can see there's pi by 2, there's pi, 3 pi by 2, and 2 pi. Dan, you've plotted yours. Yeah, that's why I never do it. I don't know why it does that. It just ruins everything. Right. You change it basically to undo what you did to the dot. Change your x min, x max, and scale, and it will reset the dot to what makes sense. Okay, can you guys now try and change yours from radians into degrees or degrees into radians so that you know how to change your trig back and forth? So if you did it in radians, make it work in degrees. If you did it in degrees, make it work in radians. Yeah, you probably have to go to shift and then setup. Go to the other angle unit.
What's the thing where like it animates a drawing graph?
I'll show you that next week. So in degrees, I'm now at 0 to pi degrees. Pi degrees is 3 degrees, so obviously my graph looks awful. So need to go to view window again. We're now going to go from 360 to -360. Scale, so we maybe want it every 90 degrees this time. So I put 90 in as my scale. And keep the Y min and max as they are. Exit, draw, and we're back to having a nice looking sine graph in degrees.
Does this mean it's really easy to like, you don't have to sketch graphs and you can find the x-axis just do this?
Yeah, exactly.
So good.
Alright guys, so after you have a play around with that, we're going to move on to a couple other bits in the equation function. And so if you go back, we've got a few different types of equations we can plot. So at the moment we just plotted y equals. Less of an issue for first years, but second years might want to plot parametric equations. So if you want to plot parametrics, you're going to go type and then choose param. And it will now set me up, not for the first one, but for the second one, I've now got 2 available slots to plot one function. And you can plot those, it will draw the parametric curve. So I don't know, if we go 2, t take +3, and sine t. Delete my first function. It doesn't look great, but it has plotted a parametric function there. I just typed in something random. So there we go. Oh, that's because I'm still in trig, of course. So if you want to go really fast from trig back to normal, if you hit standard, it will just go 10, 10, 10, 10. It still looks rubbish though, yeah. Okay, so that's parametrics. The other thing you could do is you can change an equation into an inequality. So if I change my type back to y equals, and delete all these. So let's say we wanted to plot a quadratic inequality. So let's go for x squared, take x plus 2. Once you've typed it in, if you now go to type and then convert, I can now change it into an inequality. So I've got y equals there. Let's go for y greater than. So y is greater than x squared minus x plus 2. And if we draw that, it will shade it all in like they ask you to do in the inequalities topic. So it's shaded in. It's given us a dotted line as well because I said greater than.
How did you do that?
Typed it all in. Sorry, how far have you got so far?
How do you do that again?
So you type it in as an equation.
Yeah.
Then you go to type, modify or convert, and we're going to convert it to an inequality instead.
Really nice.
So we could plot a few of those. We could also plot an x inequality. So we could say x equals, we could say x equals 2. And then we can convert that to an inequality for x. So we could say x is less than or equal to 2. Draw that, and it's shaded 2 regions of inequalities. With the correct dotted lines and solid lines.
Click modify.
Click convert, not modify. Type, then convert.
Okay.
Yeah. So type, then convert. There we go.
Click, go, highlight it, then click F3 for type, and then click F5 for convert. And then you just scroll down.
So another topic that students find difficult is finding the range and domain of stuff. So if I plot, what should we go for? Let's say, delete that. Oops, type y equals. If I plot, let's just put a random quadratic in. So x squared, I don't know, plus 3x plus 4. If I now wanted to restrict the domain on that function and see what range I was still allowed, I could plot an inequality and just see which bits were shaded and which weren't. So I could change my, let's have x is less than 2. So type, change it into an inequality again. It should work. Type, convert. I need to make it x. So make it x equals first of all. That one should do it. So delete that. So put in x equals 2. I've already got my quadratic above it. Now I'm going to change the x type to an inequality. So less than or equal to 2. If I plot both of those, I could now have a look at this graph and say, well, it's only allowed for this domain and this range. So my lowest x value would be what's included there. Highest value would go on to infinity. So you can work out by sketching inequalities over your graphs what range of domains are based on the sketches. Cool. How long have we got? 5 minutes. I might leave the rest for next week then, guys. So if you draw a line under transforming graphs, next week probably going to be about an hour and a half, and we'll go over the graph bits, some stats bits, and some of the solver bits as well. Cool. And I'll put this video up on Moodle tomorrow as well. Cheers, guys.